Okay, so I'll share. All right, so we are sharing. Okay, so I'm going to go to the virtual machine. And now we're going to finish up the other script that we started, which is actually a logic that we're going to be using several more times throughout the semester, as this is block ciphers, right? So, I'm motivating right now how to do block ciphers in code so that it's not just like theoretical things. We're doing it first, and then I'll go over the different algorithms, and we'll look at, for instance, the modes of operations and confidentiality that we were covering a week or two ago when we were using OpenSSL. Okay, so here's the virtual machine. I'm going to exit out of here. Okay, and it should be the folder XOR hash. So we started this, I believe, on Tuesday. Okay, so I'm going to go here. /L, and now we're just going to focus on this script. This one is more, the substitution one was just to kind of get you started and playing with these examples. This one is more robust. Okay, so now we are in the modern cryptographic algorithms. So the data encryption standard in AES would be based on this, right? So this is kind of like the overall framework, and those just start to get more and more specific and have more detail to them to make them more secure, if you will. All right, so let's go ahead and take a look at XOR hash. Okay, so again, we're going to repeat kind of what we were doing. So we're trying to create a, we talked about a hash, right? So what was the definition of a hash function? Who can tell me? What's the definition of a hash function? We covered this on Tuesday. It's a mapping of what? A variable length to fixed length, exactly. So, and we're going to establish here that our fixed length is going to be a block, an 8-bit block, basically. Okay, so that's going to be our goal. And so we're going to have a message, and we're going to take that message, break it up into blocks, which I think we had already started to do that. And yeah, and so that's basically how this is going to work. Okay, so you will need to create a hash of your message, okay, of your message. So I'm doing this for a sentence, and what I'm going to ask you to do probably is to just take like 2 paragraphs, for instance, right? And then out of those 2 paragraphs, create the hash value. So different, same algorithm, but larger input. Okay, guys? So your code needs to be general for that, okay? All right, so let's repeat the code here. Okay, so any questions, guys? All right, so let's go over. We had defined that we use a urandom function. Okay. That, guys. So this function, myGenKey, right, is a function that we're gonna use now just to create the initialization vector, but we could also use it to create the key, right? We just don't need a key right now for this example. Remember, the only difference between the initialization vector and the key is that you need to keep one secret and the other one you don't necessarily need to keep secret. All right, so we have this function, byte array. So this is, remember that we are going to convert all of our data to zeros and ones, even though we won't see it. It's happening here because the computer automatically converts zeros and ones back into letters that we can read. The terminal does. But we're converting it into byte arrays of a specific length. Okay. So it's just random, ones and zeros, right, of a specific length. And then here, we were working on the padding, so we are here. So we'll come back to that. And then we've defined the function getBlock, so I'll cover that again. So in this example, I have, this is a top secret message. I print the message. I've established that the length is 8. I'm going to initialize the initialization vector or key with this function. I'll print it as well. And we saw it in hex, I believe. And then I have to work on padding. So I've added, you have a question? I have the padding here, right? And that's because, as I'm asking you, grab 3 paragraphs or something from Wikipedia or somewhere like that. You know, you don't necessarily know, you know, how many letters you have in there. So this function needs to work, right? So think about it. All of you are going to grab 3 paragraphs from some source. And it's probably going to be different lengths, but we want this function to work for everyone. Yeah.
What you're saying.
Yeah.
Paragraph.
Yeah, exactly. So I'm just making it a little bit different. So in my scenario, I'm just doing 1 sentence, but for the homework, I want you to just grab more text, basically. Make sense? Yeah. So definitely today, try that out before you leave, right? Just to make sure this code works for that. Okay. So yeah, so that's basically it. So we want this function to be robust. Padding needs to be robust so that these blocks are done well, and then nothing will break. And then once we padded the initial input, then we have, you know, that's going to feed into get blocks. And then we create this list of blocks. And I believe that's as far as we've gotten. Okay. Once we have the list of blocks, we would use that to XOR, right, the blocks as we discussed in the lecture, if you remember, and produce a fixed length vector of many XOR operations. And that's your hash. Does that make sense? Questions? Good. All right. So let's go back. So let's take a look at list of blocks just to make sure we're all on the same page. So list of blocks takes the plain message, takes the length, which is 8. We created a list, right, in Python, which is this one. We used the 2 square brackets for that. We are grabbing a block because we're going to iterate through all the letters. So we have a little counter. I'm doing something similar to what I did before, if you notice, in the substitution, right? Similar idea. So 4-letter in plain, we annex it to block or concatenate to block, increment the counter. If length of block equal length, which is 8 in this case, right? Then we print the block just to see it, to corroborate, but also we need to append it to the list, and that creates our list of blocks. Okay, and then here we're just decreasing the count and reinitializing block to, once we've appended, to blank, and then that returns the list of blocks. So this we discussed on Tuesday, right? So this should be clear. All right, so now we are gonna go to padding. Okay, so I have a message here, and we know this example, I think we should run it, but I think the last one, oops. The last one was not being added to the list, if I remember. Yeah, we are here. Okay, so that's the key and everything, right? Everything works. That's so the length is 28. 28 divided by 8 is what?
3.5. 3.5.
3.5, right? So we are missing 4 letters, right? Okay, right? 3.5. Okay, so how do we do this? Think. Any ideas? Seems hard to do this, guys. Any ideas? Because we need to know, right? How many are missing, but all we know is the blocks. Block size is 8, and we know the length. So we know it's 28, and then we know the block is 8. And then you guys said 8, 16, 24, plus 4 is 28. Yeah, please.
Blocks are. If not, then adding this.
And okay, how do we do divisible by 8? That's a good one.
Create a variable for the amount of blocks we have, maybe.
Yeah, sir.
If. Eight.
Variable %8. Where'd you get this %8 from? Mod, the modulus operation, right? Yeah, it's that divisible mod. You're all talking about the same thing. Good. So it's mod, right? So yeah, very good. All right. So mod actually, we're gonna do that. So one thing I like about this class is that we touch on one thing and then we use it in the next thing. And now we've talked about mod and we'll use it in RSA. So, but anyway, so here I'm going to introduce mod, okay? Or, you guys have introduced mod. So let's go ahead and do that. So let's do that. Mod, and by the way, modulus, mod, whatever. This is just the name of the variable that I'm using. So I'm going to do mod length of message. Okay. And then %, as you said, it's an operator in Python. Okay. Very good. And then length. Oops. Right. So now let's see what that gives us. So the best way to do that is we're gonna print mod. Oops. Like that, right? So let's print it and see what happens. Okay. It says 4. You guys see that? So we knew 8, 16, 24, 4. And it gave us 4. Okay. So if I do the top secret message exclamation, what does mod give you? 5. Do you see that? So it's basically telling you, something really important here, right? That maybe, blocks are of size 8, and it's giving you this value, so then you can just take the difference and find what you need to pad. Do you see what I'm saying? So let's try that. I'm gonna do here in padding now. Oops. So I'm gonna do, just gonna create a variable called padding, and it's going to be length minus mod. And let's print padding as well. So print padding. All right, and let's just see if this solves our problem for us. So now go ahead. All right, 29. Yeah, 8, 16, 24, 25, 26, 27, 5, right? So 29. But we need to be at 32, right? Because everything needs to be blocks of equal size. Do you guys see that? So then the difference is 3, 29 to 30, 31, 32. That's the padding that we need. Does that make sense for everyone? Any questions? Okay, perfect. All right, so I'm going to go ahead then and that was the hard part, I would say. Now that we know the padding, I'm going to go ahead and just add it. And to keep it simple, you can add, something. So let's see. Again, I'm just, I love counters apparently. So, all right. So I'm going to use I equals 0 and while I less than padding. One, two, three, four. I'm going to say message equal message plus, and remember, message is a string, so the plus is concatenating something to it, right? So you can decide what you concatenate at this point. It's up to you. Do you guys see that? Any letter that you want in there. Let's just do 1 so that we can see it. Maybe the purpose of this would be that you don't see it, so maybe something like spaces, but in this case, it's a string in this case, so it doesn't matter. Any questions? Does that make sense? Okay, so, and then of course, if we're doing a counter here, we have to increment it. So I equal I plus 1. All right, and then now we can return actually message. Just like that. You guys see that? Let's go over to what comes out of padding and let's print it also. So I'm going to do print my message space. Got it? All right, so let's go ahead and hit Control X, Y, enter, clear. There we go. So this is a top secret message, the 3 ones that I added. And now you can see something that very important. The last block is being added, right? Got it, guys? And that does it for us. This is critical in particular when we start using this same approach to encrypt things with different modes of operation for confidentiality, as you don't want to cut off the message, attack at dawn or dusk, right? So here it doesn't matter so much because we're just doing a hash algorithm, but this same approach we're going to reuse again when we do modes of operation. Okay, any questions? All right, so that's basically it. Now we can pad, we can get the blocks, we know how to generate keys, and so the next step should be to just encrypt. Okay, so we have to think about the logic of encryption. I'm going to go, oops, we're going to go back to the code here. And I'm going to, so I have my message, right? And now we are ready to hash, right? So I'm going to create the hash, which remember, it should be a fixed size block. I'm going to say hash function like that. And the hash function in this case will take what? My list of blocks. Do you guys see that? Another thing we should probably do just so to make sure that we're looking at things clearly is, this is more like debugging. So you can remove these print statements once you understand things clearly, but I like to leave them in there just to kind of, since we're writing this code. So my list of blocks. There we go. We just want to see what list of blocks looks like. Okay. And we're going to send my list of blocks into the function. We also need to send into this function the key, right? Because the key is of size 8. And so that we can perform the XOR operation, which is something we haven't done yet. So I'm going to just say key here. Although remember, this is more like an initialization vector as opposed to an actual key, but it would be the same thing. Got it? All right. So now that I've done that, and then we would print the hash. And this is the thing that you would send with the message, and people would be able to check this hash to confirm integrity. Okay. So I'm going to say the hash here, and then I'm going to go and I need to define that function, hash function. Okay. Hash function. I'm just going to define it here. Okay. So define hash function colon 1, 2, 3, 4 return, and I'm going to say the hash. So I just return the hash, which is going to be the parameter. Okay. This function takes in list of blocks, and it also takes the key, or in this case, the initialization vector. We actually had this discussion, right? On Tuesday, we needed something either at the beginning or at the end to be able to start in the XOR process, okay? So we went over that logic, if you remember. So you need to check that lecture out, okay? So that's the basic idea. Now, in this example, this is not encrypt and decrypt because this is only one way, right? So there's only one way. You don't actually take a hash and convert it back to the original message, right? So that doesn't work here. Instead, you just always give it the variable length input and get that block at the end. And then when you confirm it, you're going to take that original message and you perform the same operation. Then you'll have the hash that you received plus the hash that you just created, and you just compare them in a simple if statement. They have to match perfectly. Okay? All right. We'll see later on when we do the OpenSSL lab next week that if I can take a whole movie from Netflix, and if I just flip one bit of it and hash it, the hashes will be completely different. Just changing one bit. Okay? Very important concept. All right, so let's go ahead, and that's important so that way your code hasn't been tampered with, things like that. So this we have to think about this logic, right? So this is probably like 4 or 5 lines of code at most. So, but we just have to think about it. This is where we have to take a block, each block, and XOR it with another block to produce yet another block. And then we're going to use that for the next one and so on. All right, so we have to think about that. So we're going to need 4 block-in blocks. All right, so let's try to do that. Okay, oh, and this is, so this one is hex, right? So remember, one is already a byte array, The other one is not a byte array yet. So that's also something else that we have to address. All right, so let's start with for block in list of blocks, right? 4, 1, 2, 3, 4, print block. Okay. And just so this doesn't break, I'm going to initialize the hash to nothing. Okay, so we just want to print out the blocks first. This one. Okay, so as you can see, there's the list of blocks. I'm iterating through them. And now I have to think about how to convert these into hex because I need to XOR them with this. Do you guys see that? And then once you XOR those two, they will produce a hex also, or a byte array, right? That you can use for the next one and so on. So that's what we need to figure out. Okay, so we're going to go back to this function here. Okay. Okay. All right, so this is probably the hardest part of this to understand. But if we do understand it, I think, we will be using this same concept multiple times in the future, okay? Just you have to encrypt, decrypt, and so on. So there's various stages. All right, so I have a block. Now I'm going to use, yeah, I'm going to do the following. So I'm going to do result, or I'm going to say actually block block how do I do this? So equal, and I use a list comprehension. This is a thing in Python where I can do a for loop and produce a list in it. Okay, so I'm going to do for I in range, right? Length of block, because it's size 8, right? So we know that. We've got key, which is also size 8, right? So block is size 8. Key is size 8, right? Do you agree? Okay, I think this will work. All right, so then I'm going to say key I caret block I, but we need to convert this to a number. So it would be the ASCII one, ORD. Like that. That gives you result, right? And then key equal result. How about that? What do you guys think? Do you see what's going on? So we're always XORing key. And so one thing is clear, right? This for loop grabs a block, then another block, then another block, then another block, right? And every time we grab that block and we need to XOR it with something. So initially, it's the initialization vector. Do you guys see what I'm doing? We need that first block. We only do that once. We XOR both of them, and that gives you a new thing called result, which took that initialization vector plus the first block, boom, XOR. Now we have an XOR one, and now we make that become the key for the next iteration, where we would grab the second block and we would XOR it with the result of XORing the first block and the initialization vector. And if we do that, should work. What do you guys think? Yeah? Huh? No? Yeah, no. Do you understand that logic though, right? So do you have a question? It's the same algorithm we covered on Tuesday.
Yeah, I'm just grabbing my.
Yeah, no. I know that was a lot of words. Yeah, so I like to start with this one because think about it. When we do this in encrypt and decrypt, there's additional steps, right? Now we have to encrypt, decrypt all the way. There's going to be a key and an initialization vector. This time around, there's only an initialization vector. Maybe, you know what? I'm going to change this to IV. And then here, just so it's clear that this is not actually a key. Okay, let's actually test this just to see if it actually works, right? And then we can spend more time taking all those words and saying it in fewer words. How about that? All right, so I believe this should work. Now there is the XOR operation, right? That should be clear there, that's the XOR. We did this on Tuesday also, right? All right, so did anyone try it? You guys try it? Go ahead and run it. And, oh, sorry, and we need to assign, so what becomes the hash in the end? The hash in the end should be result, right? That should be the hash. So you can say the hash, I mean, we could just send result, but to be more explicit. And we can dissect this as much as possible, okay? But yeah, let's run it. Did you guys run it? Does it error out? So that is basically,
You're right.
yeah. So no errors. All right, so let's think about it. Okay. Gonna change one letter. A different hash, right? Just by changing one letter. So if I go back to the original letter, what's the expected outcome? Should be the same, right? Same hash. That's how it checks out. Let's go ahead and try that. Oh, it's because it's a random. So I did a random thing. So okay. Got concern there. Okay, yeah. So it isn't because of the randomness, but it would have been the same if it wasn't the initialization vector had been saved into a file or something like that. So far we'll keep going on this, but do you guys get the idea of what we're doing, right? So we're giving it a variable length message, and we should get a fixed, or we give it a variable length input, and we should get a fixed length output, right? So in this case, we have 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Right? These are the hashes, right? So we're XORing the values. There are other ways of doing this, of course. So let's think about this. All right, so then I'm going to repeat the logic, right? And then we're going to think of other ways of doing it. But the function is this, right? So it should be clear, right? We have a list of blocks. How many blocks do we have in there? We have about, oh yeah, you have a question?
I was just wondering.
Yeah.
When you change key to IV, should it not also be changed in the key equals result line right there?
Where?
In one line down?
Oh, okay. Yeah, good catch, right? Like that? Okay, but that's, yeah, because that word does not exist. So yeah, that's a good one. You're right. So initially I had the word key in there, and I just decided not to have key and just change it to IV, given that this is not technically a key, it's an initialization vector, but they act the same way in a sense. And in the future, we will need to have both an initialization vector and a key. So we'll be performing this twice. Okay. So we have a list of blocks. Let's review everything, right? So list of blocks, IV. We have the hash, which is what we're trying to produce. We're going for block and list of blocks. We have 4 blocks that we're extracting. I'm just printing the block. Then here, we know that there's an XOR operation. All right, so I'm XORing. We know that IV is size 8. We know that block is size 8. So then I can just do for I in range len block. There's no errors, which means that there wasn't any like offset. They matched. So I grab via index the first element of block and the first element of IV, sorry, and I XOR. And that produces a list here, result, okay? And that list, okay, is then it becomes result here. sorry, as result, and then it becomes IV. And then in the next iteration, when I grab another block, I am comparing it to it. Do you guys see that? All right. So, and then at the end, result, the last result, right, should be the thing that becomes the hash. Do you guys see that? Again, I can repeat it, you know, let's keep going. But let's look at this again then. So we haven't run it, so let's see. Errors 1, 2, 3, 4, 5, 6, 7, 8. Why 8?
Each of the blocks is XORed, and so each block is represented by that result.
It's 8, right?
Yeah.
So the block size is 8. You guys see that? That's why it's 8. And I'm creating a list in the list comprehension. That's the thing that is adding these things that are comma separated, right? When I do in the code, the list comprehension, this thing here, this is a list comprehension in Python where I can do a for loop and the result of it is a list. I'm creating 8 items. Does that make sense, guys? Now, there's another thing that you have to understand about Python, right? So Python is built kind of on top of C and C++. So on the underlying things, the variable types and everything is represented as a very low level. So like it's all hex. Even though we see a 3, it really is like a hex. So that's why even though here I'm creating this, it's able to process it. Because we know this is a byte array, right? If you remember, this was a byte array. Do you agree that this was like hex initially at some point when we printed it? You guys know what I mean? Whereas this is like a number, 11, but that's how we see it, but not how it's represented. At the low level, they're all represented as hex or binary. Does that make sense? So that's why these operations work in Python. Got it? The string wouldn't work, obviously. String would not work because it's number types, right? So when we convert it, it works. Any questions? Questions? All right, so you might want this to be in hex. So that's the next step, right? So how do we do that? What do you guys think? Could we just do like byte array maybe? Because we're seeing a list, right? So, but you may be, well, we haven't done the OpenSSL lab actually. So when we do the OpenSSL lab and calculate the MD5 and the SHA-1 and the SHA-256, what are you going to get? You're actually going to get sequences of hex numbers. You know, that's going to be your hash value or something like that, right? So how can we do that? So we know that the function byte array, random length. So let's start here. Let's take a look at, so let's run an experiment. What do we get when we just run random length and print it on the screen? How about that? Right, so I'm going to do print random length, right? So we just want to understand what that gives us. It's going to be the last value we get. Okay, that gives you already a binary. Okay. And it's got the B in front of it. Okay. How do we convert hours? Let me just, I'm just going to try that. I don't think it'll work, but let me try this. Kind of work. Right? Do you guys see what I'm, so it took the list actually and made it into a byte array. So these functions in Python are always so like robust. So now I'm gonna go here. I'm gonna remove the last one, which might be confusing, this one, right? So I just added that for debugging purposes. I'm saying that when we use OpenSSL, the hash will not be a list of numbers. It's not gonna look like that, most likely. It will look like hexadecimal values, okay? So a string, basically. So then what I was trying to do is, even though I did all this logic here, I wanted to finally convert the hash to something that looks a little bit like that, right? And so I'm doing this return the hash, but as a byte array. So it is a byte array. So what's the hash? It's only this part here, right? So not what's in the single quotes. Does this make sense, guys? Everyone with me on this? Does it make more sense now? Okay. All right. If you have questions, ask. So for your homework, we have about 13 minutes left. So ask all the questions that you want. I want you to take 3 paragraphs, remember, something bigger, and run it through this and get a hash. But you need to corroborate that it does in fact work, right? So you need to understand now this was the algorithm, now there's the usage of it. So I kind of want to add that you should work with a partner on this one, right? And just take a file, 3 paragraphs, hash it, send that to your friend, and what should they do? They should take that message, those 3 paragraphs, through the algorithm, obtain a hash, compare them, and they should be the same. That's what hashing is about. Do you guys understand? So you have to modify this code. There's one problem with this code, right? What's the problem? It's random, the randomness. You got to fix that somehow. Okay. Do you understand? That's the homework, okay? I'll add this problem right now and then in the 10 minutes. It's just more fun, right? So we went over the algorithm. We will repeat this again next week with OpenSSL. The only difference then is that it will be OpenSSL. So it'll be more like the command line thing that we did before. You'll take a file, whatever it is, produce a hash, send it to your friend, and they will check integrity. The goal is that you should understand what's the purpose of this number, right? So every time you give it a file, it should return the exact same value, as long as you haven't changed the file. Be careful how you send the message via email. Email sometimes changes like formats, copy, paste, things like that. So if something changes, in theory, it should be a different hash. Got it? Any questions?
You're supposed to get the same thing. You just don't use random now at all.
That's right. That's exactly right. So you have to figure out, because the initialization vector needs to be the same, right? That's the whole point. So the point of integrity is what? You give it a message. If that message has not changed in any way, it should always produce the same output, right? And then you're going to email your friend the message, and this was my hash. And on their end, they have to take that message, run it through the algorithm, produce a hash, compare those 2 hashes, and they should match. And that's what gives you confidence that, okay, integrity was maintained. Got it? So exactly. I mean, you can explore urandom. These functions sometimes have something called seed. It's a parameter. Just if you set that parameter to like 42 or some number, it will always give you the same value. I just don't know the exact syntax of this one, but most of these functions have a seed parameter. So, Google it, right? So Google urandom Python seed parameter, set it to some specific number, and hopefully it will always give you the same initialization vector, have the same message, three paragraphs. You should get the same result. Got it? The code works, right? You agree, guys, that the code works? And then when you send this to your friend, basically, you'll send them this, right? And then they'll say, hey, check the integrity, and it should match. Any other questions? Yeah, please. Like work together on that part, and just like, you don't have to send it just one way. Like, let's say Cody, Tyler, what's your name? Justin, right? So Tyler and yeah, sorry. So Tyler sent something to Justin, and that's it. That you guys work together, right? And then you can just show that scenario in your report. So you can have that part that's the same. Got it? Make sense? So we'll do this a lot, guys. So just figure it out, okay? You have to send from one party to the other and show evidence that you succeeded in the task. All right, so I will add this as a problem, as an additional problem to the XOR hash algorithm. And remember, that has to do with, one is the algorithm part, and then one is the usage part. So I'm going to change this a little bit. So complete the XOR algorithm as discussed in class. See attached Word document, and then I'll just add in here, okay? Work with a partner, okay? So then create a scenario, right? Scenario where you take 3 paragraphs, right? And hash this message, okay? Then send the message and hash to your partner, right? And then what? Your partner should check the integrity of the message and make sure that the hashes match. Is that clear enough? Would you like me to say something else? So work with a partner, create a scenario where you take 3 paragraphs, any paragraphs, and hash them, then send the message and the hash to your partner. Your partner should check the integrity of the message and make sure that the hashes match. Is this clear enough? Guys, clear enough? Yep. All right, so that's basically what you need to do, okay? Oh, all right. All right, so yeah, work with a partner, create a scenario where you take 3 paragraphs, the message, and hash this message. Then send the message and the hash to your partner. Your partner should check the integrity of the message and make sure that the hashes match. Okay. Any questions on what you need to do? So yeah, so create the scenario, work with someone, and yeah, that's it. All right, so I'll stay for a few minutes if you guys have any questions. Otherwise, yeah, work on this and I will see you on Tuesday of week 4. Remember, we are now at week 4. Already, next week is week 4. We've completed 3 weeks already. Next week is week 4. So be aware of that. All right, I'll stop the recording right now.